I'm Matt Nyer. I'm a Senior Applications Engineer for Makino, and I'm here with today's tech tip on assigning program tool numbers. All right, so we're looking at assigning tool numbers outside of the normal pot range, okay? I'm here to explain to you there may be some benefits to this, benefits that you may not be aware of. So on most machines, when you call a tool, it's a fixed pot machine, it's in tool 1 or pot 118. We're going to call that by T118M6, okay? Which is fantastic. Here on the DA300P, we have 118 tools, 120 pots. 2 of them are transfer pots. So we actually have up to 120 in our pot number, okay? So right now we are set up to currently call tool 119 in pot 119 by calling that exact number, okay? Now there's some downsides to this. So, and that being that, let's say you set up a bunch of different jobs. You're not running just one job. You do a high mix of work, and you may not have a set tool numbering system that always puts these tools in the same pots. Or you may have a bunch of jobs that actually you have more than 118 tools total. So you end up pulling out certain tools or adding tools into the system. And it can become confusing if, let's say, pot number 119, one time is a 1/2 inch end mill. Next time it's a 1/4 inch end mill. There's nothing to differentiate. It's just tool 119, okay? And it would also be something if you had a bunch of tools to put in, but you had a lot of empty pots on one side of the ring that you couldn't utilize because these tool numbers were early on or tool numbers that somebody happens to use all the time. How do we get away from this? And the way I get away from that is with the Makino in our tool data page, we can actually start with a 4-digit number here. You could start at 1000 and work from there, thus breaking the correlation between a pot number and a tool number, okay? So if I have 5 tools to put in the system, I no longer care what pot number they go into because my tool number is completely independent. I just go back there looking for empty pots, which I can stick the physical tool in and then assign the correlating number to the tool number under the tool data, thus telling the programs in the machine to call those tools by those numbers. What else does this give us? Well, if you program a lot of jobs that you use a CAM system, such as Master CAM, you can create tool libraries, master tool libraries, okay? Now you can go from 1000 to 9999. You could even break it down as, hey, anything in the thousands are end mills. Anything in the 2000s are drills. Anything in the 3000s are corner rounding end mills. So you can give some identification to tool numbers and tools that are being put in the machine so people know what they should be putting in case there's a massive discrepancy. But it allows you to carry a master library and use that master library to program across all your jobs because you're separating the information. Every tool has a unique tool number. Also on these machines, we have collision safeguard. If you get to a point where you're using level 2 collision safeguard, it is really great to have a master library that all your jobs can pull from. That way, if you need to switch tools at the machine, you're not redoing a collision safeguard project. You're literally changing the tool number, and away you go. So how do we assign a program tool number? We come into the tool data page here. We enable input mode. We find the tool that we want to change the number to under the tool number column. I'm going to call this tool 1019. Okay, just added. Made that a 4-digit tool number. If I want to call this tool, I can now go to MDI and I go T1019, M6. We hit cycle start. It now grabs that tool in pot 119 because we've associated that tool number with pot 119. All right, that was today's tech tip. We're assigning a tool number that does not match the pot number, in this instance, a 4-digit tool number, so that we can add flexibility to the tooling system and the tooling management on the DA300.